morning.
First thing I'm going to do is I don't know if clear up, cover up, fix something, but there was an issue that I want to get done right now. Last time I rushed through these reference numbers and I wasn't clear, at least based on some people having issues with some of the questions, what I meant by this t bar. Right, so you've got an angle that's too big, so you take away 2 pi, you take away 2 pi, and you get an angle. But t bar is in fact the shortest distance to the x-axis. What I didn't make clear is it doesn't matter which side. So that x-axis is over here as well. So that does make calculating this reference angle t bar a little bit more complicated than I think I made it look in the couple of questions that I shot through. So let's do it a little bit slower now. If the original angle is 1/4 pi, right? If it's in the first quadrant, then the reference angle and the original angle are the same thing. Can you see that distance there, for instance, is pi upon 4 in both cases? Now, if your angle moves into the second quadrant, you know, like this angle here, which is 2/3 pi, then t bar, the reference angle, is the shortest distance to the x-axis. And in this case, it's the x-axis over here. And to get that angle, then, what you need to do is you need to take pi, which is there, right? That's 0. That's 1/2 pi. That's 1 pi. That's 3/2 pi. And then back there is 2 pi. So you take pi and subtract 2/3. So this reference angle is that shortest distance to the x-axis. So if the angle was 2/3, the shortest distance is 1/3 pi. If you move over to the third quadrant, then, for instance, 5/4 pi is in the third quadrant, then if you want to get the reference angle, it's the original angle take away pi. And lastly, if your angle happens to be in the fourth quadrant and you want to find the reference angle, the shortest distance to the x-axis is in fact 2 pi, take away the original, in this case 11/6. So I'll keep that up there just for a few moments. You can either watch the video again, but that's the precise way to calculate it. I think when I shot through it yesterday, I was far too quick and maybe I didn't go into this or make it as clear as I meant, right? It's the shortest distance to the x-axis, but the x-axis goes 2 ways, right? That's the thing that I didn't emphasize. So hopefully that'll clear up some of the issues. So far, so good. Right. Let me load up some homework questions and kind of show you that issue and get it fixed right now before you get too caught up in your homework. Okay, I'm almost there. Okay, now I've left the solutions on this one just so that we can see the t-bar question, if I can find it now. Okay, there we go. Right. Consider the angle 2/3 pi. Right. Hopefully you're looking at question 27. Is that right? Is that what you're saying? Yeah. Okay, so I'll make it a little bit bigger because some of your screens might not be as good. There. Original angle is 2/3. Now, if you imagine where 2/3 is, it's actually in the second quadrant, right? It's 0, 1/2 pi, 2/3, right? It's in the second quadrant. And the second quadrant, then, that's this guy. And you get this guy because it's in the second quadrant, it's pi, take away 2/3 pi. And that's where their answer comes from. Are you comfortable about that now? So the reference angle t bar is the shortest distance to any of the x-axis, to the x-axis itself. Now, to find the terminal points, we've covered lots of them, so hopefully that won't be such a big issue. Here we go. I'm using this guy again. Right, 2/3 pi is here. Do you see it's in the second quadrant, like I said? Then the shortest distance is from here to here. And that's the t bar, 1/3. But isn't the terminal point -1/2, √3/2? We're cool about that. Right, so and the terminal angles is what it's always been, right? I haven't changed that. But you might want to think about the t bar one. Right, so the next one you cannot see, but I'm telling you what it is. It's 5/3 pi. Right, so if you look at this diagram, can you see where 5/3 pi is? Isn't it in the fourth quadrant? Okay. So won't its terminal point be 1/2, -√3/2, right? So for 5/3 pi, the terminal point is 1/2, -√3/2. But won't t bar, the reference angle, be that distance? And 5/3 up to 2 pi, take 2 pi, subtract that guy, and that angle is 1/3. So you would write down 1/3 pi for t bar, and you would write this guy here is your terminal point. Am I flogging a dead horse here, or are we good? Am I just making a meal of it? Are you comfortable what I'm getting at with the t bar thing, the t bar thing, right?
I think so.
Okay, so if that's the case, yes, go for it.
Why does it? Why is that based off of the x-axis? Why can't it also be the y?
It's defined that way. It's always been used as the x-axis. So when they started doing it, they say, look, you got to pick one, because if you pick two, won't you pick the y and somebody else picks the x's and nobody agrees, right? It's one of those. Everybody in math decides you never need to write 1x. Don't you just write x? Right? We just made it a rule. So x is the axis, and you live with it. Right. So I now want to show you our next section, because that's basically 5-1 finished. Oops. Give me a second. I'm not what I'm doing here, hitting buttons everywhere. There we go. I'll tell you a joke. I need a joke before we do it. Plus, it'll give anybody who still wants to do a little copy of this down. Right. There was this student, you'll like this joke, Matthew. There was this student who was a Seahawks fanatic. He wears Seahawks, baseball cap, t-shirts, you name it, he's got it, right? His pen had sales, all of that. But he never wore them to college. The only time he wore his Seahawks stuff was when he went for exams. He only wore it during exams. And one day his friend stops him and says, why do you only wear your Seahawks stuff for exams? And he says, well, I know if I wear my Seahawks stuff, I'll pass even when I shouldn't.
Yeah, that was good. That was good.
Right. Only some of you know the context of that. So I understand that the jokes don't always make sense to everyone. I'm going to tell you another one. I guess I'm in a tell joke mood, but if I have a joke come into my head, I have to tell people, otherwise it just distracts me and I make mistakes and so on. As you kind of notice, I'm kind of distracted right now. So here goes. Scottish guy and his wife go to America on holiday for their wedding anniversary. And they go to a state fair and they're watching this little aircraft, a little old-fashioned aircraft that would take people up and just do a little, tour of the surroundings from there. And he looks at his wife and says, that looks like it's fun. I think we could try that. And so the aircraft lands, and it's one of those aircraft where the pilot's at the front and then the people sit behind them, right? It's like in a straight line. And, open topped, all that thing. And he goes up to the pilot and says, how much is it for me and my wife to, do that tour? And the pilot says, oh, it's $100 each. And the Scots guy says, oh, that's too much money. I'm not going to pay that. Can you make me a deal? So the pilot looks around and there's nobody else wanting to use the thing. So he says, okay, I'll make you a deal. It's just $100 for both of you. But if I hear one scream or shout, I want my $200. I want my full rate. And so they agree, and the pilot gets in the front and the Scotsman and then his wife get in the back, and they take off, and it's going, quite nice, showing them the place. And finally the pilot's thinking, no, I want all my money. I'm not going to settle for half. So he starts doing crazy things to see if he can make the guy scream. So he heads towards a mountain, and at the last second he veers off. Nothing. Crashes towards the ground as if he's going to, hit the ground, and then at the last minute, nothing. Does loop the loops and flies upside down. Still nothing. So he kind of gives up, and he lands the aircraft and meets up with the Scotsman, and he says, okay, a deal's a deal, that's $100, and he gets his money. And then the pilot says to him, it must have been really difficult for you to keep quiet. I did everything I could think of to make you shout. And the Scotsman nodded and said, it was really difficult. I almost screamed when the wife fell out.
That's a good one.
Yeah, I should warn you that most of my Scottish jokes, I guess it's just Scottish sense of humour, tend to have violence, right? But you got to remember that no real person died in the making of that joke, right?
Mm-hmm.
It was just a joke. Okay, we are ready now to continue to our next section. I'm drawing, I don't know why I closed that window. I'm going to be drawing a unit circle again, at least making an attempt to draw it. Because we're going to look at what are called the trig ratios. So on a unit circle, let's pretend that's a unit circle. There we go. If I pick any point at random, and I'll call it P, and I'm just going to call its coordinates X and Y, right? There are 6 trig ratios, 6 trig functions. And I need more paper here. Oh, let's put a little angle in. Right. And I'm going to call that angle that little letter there, because that's quite a common letter in trig. That letter that looks like a 0 with the stroke through it is called theta. And back to this now. So the X coordinate is the sine of theta. So if you're wondering what is the sine of an angle theta, like pi upon 3 or pi upon 4, it's the X coordinate in its unit circle. And the Y coordinate then, and darn it in space, I know I was distracted. There we go, got it right way down there. X is the cosine of theta, Y is the sine of theta. If you take Y and divide it by X, you'll get the tangent of theta. There's a fella called a trig ratio called the secant of theta, and you get that by 1 over X. You've got a guy called the cosecant of theta, and you get 1 over Y. And lastly, you get a guy called the cotangent of theta, and you get that by finding X over Y. So the trig ratios that you may have heard, like the sine function and the cosine function and so on, all of those trig ratios can be found in a unit circle. So if I know what point, right, the terminal point is, the X coordinate will tell me the cosine, the Y coordinate will tell me the sine, and these are the others. So I have got over here, I'm not sure how clear it is, but I have got here a unit circle, and on that unit circle we've got the key angles, and here are all the terminal points. So if you've got this guy in front of you, you can actually find the sine, cosine, tangent of anything you like. So, for instance, if I asked you for the sine of 45 degrees, you'd go to your unit circle and you'd find that terminal point, right? Now, is the sine the x or the y coordinate?
Y.
Okay, in this case, that's the y coordinate. In this case, that's root 2 upon 2. Now, if I asked you for the cosine of 2/3 pi, you find 2/3 pi, right? You see the x and y coordinate for 2/3 pi, right? Now, if you want to find a cosine, isn't the x coordinate? In this case, it's -1/2. Suppose I wanted to find the tangent of 7/6 pi. Right? You find 7/6 pi and you find it's, right? You find that point. It's the y coordinate divided by the x coordinate. And in this case, it's -1/2 divided by, right, -1/2 divided by -√3 upon 2. Now, these guys here, you didn't need to do anything. They're totally fine. Would you agree, I hope you agree, that it's probably not a good idea to leave your answer like that? Would you agree that's ugly, right? And so we are expecting you to simplify some of these answers, in particular, a tangent, for example. Now, this is the slow way to do it, but top guy is -1/2 divided by the bottom guy, which is that. So far, so good, right? Top divided by bottom. Do you remember that dividing a fraction is the same as multiplying by its reciprocal? You remember that? Now, we can tidy this up quite a bit. Would you agree that a 2 in the top and a 2 in the bottom cancel? And would you agree a negative and another negative makes the answer positive? So would you agree that the answer becomes a much nicer looking answer, right? It's now 1/√3. And you might say, well, that's great. Can we leave that? Sorry, you're not allowed square roots on the bottom, right? So you must fix that as well. So that's probably going to be the last thing you're going to fix. The fancy name for what I'm about to do is called rationalizing the denominator. And essentially, you fix this fraction, you change it by multiplying it by a special version of 1. You remember that trick? Make the square roots in the bottom go away. And so what we're now left with is √3 upon 3. So the answer to this one would be √3 upon 3. Okay, so this section 2 that we're on, is really about finding versions of these guys. So they'll give you an angle and they'll ask you to find the sine, the tangent, the cotangent, whatever it happens to be. And as long as you remember these 6 formulas and that you can get all your answers by using the coordinates of the terminal point, you're well on your way to doing at least half of the questions in 5-2. Right now, I'm just opening it up so I can pick some questions. So let's see if I can pick one. Take that guy. The sine of 5/6. 5/6, sorry, 5/6, 1/6, right? So there's my guy. Wouldn't my answer come from here somewhere? Right. Same question as before, X or Y coordinate?
Y.
Okay. And so the answer is a half. If I asked you for the cosine of 7/4 pi, won't you find it? And you look down there and you know that the cosine is the x coordinate. So you get that. If I asked you for a cotangent of 7/6 pi. Right now, 7/6 is here, right? I'll write down its coordinates in case you can't see them. It's that guy and that guy. According to my little, whoops, where's it gone? According to my little formula over here, isn't the cotangent the x divided by the y? And so in this case, it's going to be this fella divided by that guy. Put little brackets around them. And then won't you do some scratch working at the side, not unlike this one here, and make it look pretty? And can you just trust me that the answer to that one ends up being root 3. Are you okay with that? So if I give you any angle that is inside the unit circle, right? So it has to be from one of these to be able to do this. Do you feel comfortable you could get the sine, the cosine, the cotangent, and for those that you need to, make them look pretty, okay? And so essentially making them look pretty is, if you have to divide them, divide them. And secondly, if there's a square root in the bottom, get rid of it, right? If you do those two things, you've made it look pretty. Here, I doubt if you can read it unless you've got a really big monitor. I can hardly read it, but it's, you trust me on it. What they've got here is all the angles, then all the things in radians, and then what the sines, cosine, tangents are. So virtually every answer in the world is in that table. But I think it's much better if you just get comfortable in using these formulas, right? And that way, you know, if you ever come across one, you just need a unit circle, right? You don't need some massively big, ugly table that you might or might not read properly. Are there any questions so far, or are we good? We are good. So, oh, you might wonder why they're called trig ratios. Well, basically, isn't a ratio just a fraction, a combination of things? And so you notice a lot of these answers are fractions. That's the only reason. They're also called trig functions. If you've done trig anywhere else, haven't you done things like, you know, y equals sine x, and you've drawn it and whatever. You might have done that in your high school life. Well, if this is going as good as it can be, I now have to make things hard for you, right? So it's not going to be too difficult, I hope. But you might have to do that guy. 7/3 pi. And hopefully you'll go and say, wait a minute, there isn't any 7/3 pi. Isn't that because that's too big? Right? It's more than one circle. So you might have to do this step. 7/3 is too big. How do you get it into an angle in the 0 to pi range?
Subtract 2 pi.
Okay, which is basically subtract 6/3. And if you do that, can you trust me that you've now got that? And then can't you use your unit circle and you've got your answer, right?
Yeah.
Do you know that T bar, the terminal thing that we were talking about, the reference angle, the T bar? Can you forget about that for this section? Because all you're going to do is take away 2 pi or add 2 pi, and that's the number. Because in a unit circle, don't you have everything you need? You don't need to tweak it, right? So if you're wondering what that T bar has got to do with this section, it's got absolutely nothing to do with this section. So pretend you don't know about it. Just do the usual add or subtract 2 pi, which is kind of where my mind was yesterday. You could get, oh, by the way, since we're there, might as well finish it. It's 1/3, the y coordinate, then there's your answer. How about the cosine of -11/2 pi? Would you agree that's not in the 0 to pi range either? So you're going to have to fix things when that happens. We did this yesterday. What do you do to figure out what that's the same as or equivalent to? What do you do to negative 11 halves pi to get it so it's inside this range of values?
Add
2
6
pi.
pi.
Add 6.
Oh
Pi.
God, you are well ahead of the game. I was hoping just to hear add 2 pi, and then I would do it and say, oh, it's not enough, and then you'd say, well, just add some more 2 pi's. But if you get, as you did, hey, why don't I just cut to the chase? There's 11 halves, and then I'll add 6, right? And that ends up being, I know it's a half, but I'm just doing it for completeness. That ends up being a half pi. And when you go over here, can you see that the x coordinate is 0? And there's your answer. Are we just getting that used to these that you know sometimes you add 2, 4, 6 pi, or sometimes you take away 2, 4, 6 pi?
Yeah.
Which is
It's
great
not
because
that difficult.
it isn't really. I'm looking for some other problem ones, but they're really just getting you lots of practice at doing this. I don't see anything particularly weird. I know what I'll do. I'll give you 6, right? One of each of the 6 trig ratios. And I'm only going to give you, I'll keep this here so you can use it. I'm only going to give you, I don't know, 3 minutes, right? 30 seconds each to see how many you can get done. So there's going to be all 6 ratios. I'm going to do a sine of somebody, cosine of somebody, a tan, a cosecant of someone. Oh, by the way, a cosecant, right, is that guy, right? What else have I got? Secant, and lastly a cotangent, right? So that's all 6 of them. So here goes. Nice, easy one to start with. And I've deliberately put some weird ones in here. Okay, starting now. You got 3 minutes. Go for it. Find all of these guys. I'm trying to think what I need to keep handy. Can I keep that one handy? Is that the one that's more useful? Or do you want to see the formula one? We don't really have room for both. What do you want?
Unit circle.
Unit circle you got. Go for it. One of these answers is really, really weird, and it's okay because it's meant to be. think we're on. Last few seconds. Okay, here goes. If you want to find the sign of something, you find its y coordinate. And this one is good to go. So the y coordinate was √3/2. Hopefully you got that one. Right. Now 5/4 pi is here. And for a cosine, you're going to use the x coordinate. And that happens to be -√2/2. Hopefully you got that one. Now, do you notice this one is kind of, actually it might even be a carbon copy of the one that we had. It's kind of big, isn't it? 11/2. If you keep taking away 2 pi's, eventually don't you get to something that fits? What does this end up looking like when you do that? What's 11/2?
1/2 pi.
So where am I putting? I don't know what to do. Green. It's 1/2 pi. And if you're doing a tangent, it's going to be the y over the x. And if I look at a 1/2 pi and you do the y over the x, do you see that weird answer I was worrying, kind of doing, warning you about, right? What is 1/0? It's not 1, it's not 0.
It's undefined.
It's undefined.
Oh.
So that was the answer to that one. Now, if you want to do a cosecant, it's basically just 1 over the y coordinate. And so let's find out where 1/3 pi is. It's over here again. And if you do 1 over the y coordinate, you get that, which becomes eventually that. And then I hope you had enough time, although you might not, that you made it look pretty. So cosecant is 1 over the y coordinate, 1/3 pi, make sure I did this right, 1 over this guy, well, 1 over √3 gets you that, and it becomes this. Right, a secant, isn't that negative? So don't you have to add 2 pi? And if you did that correctly, I believe you got 4/3 pi, which means we're going to be over here somewhere. There we are. And to do a secant, it's 1 over the x coordinate, which in this case is 1 over -√3/2. And I don't have enough room to do all the working, but eventually it becomes that guy. And lastly, we have a cotangent. 7/3 is too big. If you take 2 pi away from it, you get 1/3. A cotangent is the x coordinate divided by the y. And for 1/3 pi, which seems to be one of my favorite go-to combinations, in this case, it's going to be 1/2 over √3/2. I want to show you a little shortcut here. Do you know that when you do tangents and cotangents, you're always going to have a fraction and another fraction like this one here? And you can certainly do first fraction divided by second reciprocal, but here's a little shortcut. The 2's cancel out. See, that's a lot easier to do, isn't it? 1/2 over √3/2. The 2's essentially cancel each other out, right? The 2 in the bottom here cancels the 2 in the bottom here. And that guy can then be tidied up in the usual way. Right, so hopefully you had enough time to do all of those. Do we feel comfortable then that if I give you an angle, you notice I'm doing them all in radians, but we could have done them in degrees, couldn't we? That you can find any one of the 6 trig ratios, even the weird ones that end up being undefined. Does that seem reasonable? Do you feel good that you could do that?
Can we go over number 5 again?
Yeah, this one here, sure. I'll take it a little bit slower. So we're being asked to find that guy, right? Now he is not in the range 0 to 2 pi. So some scratch working, what I did is I added 2 pi to it. And if you take -3 and add 2 pi, you get positive 4/3 pi. So that means I'm looking for the secant of 4/3 pi. And I need that because I need an angle that's in here. Now the ratio for a secant is, where did I put my secant? It's down here somewhere. Here it is. The ratio for my secant is 1 over the x coordinate. So it's going to be 1 over the x coordinate. Now I can use this guy and I can find 4/3 pi, which is here. And oh, did I do that wrong? I think I did that one wrong. I did. That might be your confusion. Did you have 1 over -1/2?
Yeah.
Yeah, and that ends up being eventually -2. So that one there, I picked the wrong number, right? I picked the other guy. So that one there is in fact -2. I guess the moral of that story is just be careful, right? Make sure that you're using the x or the y depending on which one that you're being asked, which ratio you're being asked to calculate. Do I need to do some of these with degrees? You know, same kind of question. Are you comfortable that I only did it with radians? I mean, you could be asked for the sine of 30 degrees or the tangent in 90, right? Are we good not doing them, or do you want to see me do some degree ones as well? Just looking at faces, don't see any. Great. Could we do it? Okay. I'm assuming that means we're cool. Well, what do you do if you have a unit circle, right? And you want to know what the sine, the cosine, you know, one of these guys are. But I don't tell you the angle. All I tell you is the coordinates of a point on the unit circle. And imagine they have an angle then, right? And we typically call this angle T or theta. Let's call it T. I like theta, but we'll call it T. I can find all 6 trig ratios of this angle T, even although I don't know if it's 30 degrees or 22 degrees or pi. I don't care, because isn't this all you need? So for instance, if someone went and said to you, what is the cosine of angle T? Are you going to say, oh, well, that's the x coordinate? And you're right, it's just 4/5. If I asked you, what is the tangent of this angle? Well, that would be the y coordinate divided by the x coordinate, which would be 3/5 divided by 4/5. Anybody want to tell me the shortcut answer?
3/4.
Right. Remember what I said, the 5s cancel out? Doesn't that make it easier? At least it reduces your workload, right? So you're going to get questions where they tell you the terminal point and they ask you for sine, cosine, cotangent, whatever it is. Doesn't really matter what they ask you. Would you agree that as long as you know the x and y coordinate, can't you find any one of the 6 trig ratios? You don't need to be told that's 22.5 degrees or 4 pi or 8.1 pi or anything else. To find the angle, right, to find the trig of that angle, you can do that automatically. That's kind of cool, isn't it? So, by the way, that's a version of question 12. So let's do a new page, I think. Let's do a version of question 13. If you've not done WebAssign, I think I have mentioned it to you, that they've randomized the questions. so that everybody gets a different, virtually everybody gets a different question 13. That's my question 13. It's not going to be yours. Now I know the X and the Y coordinates, and they are going to ask me to find the sine and let's say to find the tangent. If you want to find the sine, it's the Y coordinate. And in this case, 4√3/7. Now, if you want the tangent, it's going to be the Y coordinate divided by the X coordinate. That's not going to be pretty. It's going to be 4√3/7, that's the Y coordinate, over -1/7. But can't we use our little shortcut trick? What will that simplify down to?
4√3/-1.
Agreed? And in this case, won't that simply just become -4√3? Do you see how easy it is if you use the shortcut? And that's it. They're not asking you to do a great deal in this section. They're basically asking you to find the sum of or all of the 6 trig ratios, either be by telling you the coordinates of a terminal point, or by giving you an angle, in which case you have to use the unit circle to find the terminal point. That's really the only difference. In these questions, you're told the angle, that leads you to the terminal point, then you can get your answer. In these questions, they cut out the middleman and just told you what the terminal point was, and you can still find the trig ratios. We go. Don't know. Okay, let's pick this one. I just saw some really ugly fractions. Square root of 17/7, comma, 4 square root of 17/17. And let's just find the tangent. So there's my X, there's my Y. The tangent is the Y coordinate divided by the X. 4√17/17 over √17. Oops, there's a 17 there as well. √17/17. Okay, tell me, what does that horrible fraction simplify down to?
Would it be 28/17?
So I had 4 √17s. What would go in the bottom?
17.
Do you mean √17?
Oh,
Yes? Right. Don't those cancel out? Oh, wait a minute. Can that be simplified? 4 is 17 on the top, √17 on the bottom. Can that simplify?
just a 4.
Just a 4. So always be on the lookout for, something that may simplify. That was actually, I like that question.